In this example, we're asked to factor f of x into linear factors if we're given that the k that's given in the problem is a 0 of f of x. So what we'll do is we'll set up synthetic division with the given information. We'll use our k value as given as the number 5. We'll use the coefficients, making sure that every power is represented of the given polynomial f of x. So our coefficients are 2, -7, -24, and 45. We'll bring down the first number 2, multiply to get 10, subtract since our signs are different to get 3, multiply to get 15, subtract since our signs are different to get -9, multiply to get -45, and subtract to get 0. Now we expected to get a 0 because we were told that k equals 5 is a 0 of the function. What we're asked to do is to factor into linear factors. Since we were given that k equals 5 is a 0, then we know that x minus 5 must be a factor. So this means that x minus 5 must be a factor since k equals 5 is a 0. And that's from information that we learned prior in this material. So what we'll do is we'll start factoring this out. We say f of x is equal to, the first factor that we found is x minus 5. Since k equals 5 is a 0, x minus 5 is a factor. If we look here, we're left with the polynomial that comes from these numbers that we got in synthetic division. So we say times 2x, remember we go down 1 power from the given power. Given power is 3, so we go down to x squared, then plus 3x minus 9. Now we need to factor the polynomial that we have left because it said factor into linear factors. So linear tells us that the highest power that we can have for each of our factors is a 1. So we factor out this trinomial, factor out a 2x and an x, and then we'll have minus 3 with the 2x and plus 3 with the x. So this would be our factored answer. Let's continue on with an example from factor f of x into linear factors if we're given that k is a 0 of f of x. Part B of this example, we're told that k equals -4 is a 0. That means that x plus 4 is a factor. So what we'll do is we'll set up synthetic division. We expect to get 0 as our remainder. We use 3, 2, -37, and 12, bringing down the 3 first. Multiply 3 times -4 to get -12, subtract to get -10. Multiply to get 40, subtract to get 3. Multiply to get -12, and subtract to get 0. As we expected, we got a remainder of 0. What this tells us is that x plus 4 is a factor. Since -4 was a 0, x plus 4 is a factor. So we can begin factoring it out by saying that f of x is equal to, our first factor is x plus 4, then what we have left is this polynomial taken from these numbers here. So we have 3x, go down a power from the highest power in the given problem, which was a 3. So we go down a power to get squared, minus 10x plus 3. Since we were asked to factor this into linear factors, then each factor must have a highest power of 1. So we factor out this trinomial. We get 3x minus 1 and x minus 3. And this would be our polynomial factored into linear factors.